Good day, sir. We are here to demonstrate our research about the topic to components of the body that cause human beings to move. So first, let us know what is skeletal system. Skeletal system provides support and protection for the body's internal organs and gives the muscle a point of attachment. So, the human skeleton can be divided into two components, and those are the axial skeleton and the appendicular skeleton. What is axial skeleton? So, axial skeleton is formed around the central axis of the body and thus includes the skull, the spine, and the rib cage. It protects the brain, spinal cord, heart, lungs, esophagus, and major sense organs like eyes, ears, nose, and tongue. So, in other hand, appendicular skeleton is related to the limbs and consists of the bones of the arms and legs, as well as the shoulder and the hip girdles. The skeletal system is composed of four main types of connective tissues, and those are the bone, the ligament, tendon, and joint. So first, let us know what is bone. Bone, a rigid form of connective tissues that is part of the skeletal system of vertebrates that is composed of principally of calcium. Second is ligament, a small band of dense, white, fibrous elastic tissues that connects the ends of the bones together, form a joint, or assist in holding organs in a place. So third is tendon, a tough, flexible, and inelastic band of fibrous connective tissues that connects muscles to the bones. And lastly, the joint. Joints hold the bones of the skeleton together and support movement. They can be grouped together by functions and structures, such as ball and socket, hinge, and pivot joints. So let us proceed to the types of bones. So we have 5 types of bones, and these are the long bone, short bone, flat bone, sesamoid bone, and irregular bone. Let us go first to long bone. Long bone helps to facilitate movement and support the weight of the body. Long bones are characterized by long tubular shaft and articular surface at each of the end of bone where ligaments and tendons attach. These bones include the major bones of the arms and legs, such as the humerus and femur, tibia and fibula, and the radius and ulna. Second is short bone. Short bone helps to provide stability and movement within the ankle and wrist joints. Short bones are roughly cube-shaped and are as long as they are wide. Example of this bone include the carpals and metacarpals in the wrist and ankles. The third one is flat bone. The primary purpose of this type of bone is to protect the internal organs such as brain, heart, and lungs. It also provides a large surface of muscles to attach to. Examples of this type of bone include the cranium, which is the skull, the thoracic cage, which is the sternum and ribs, and lastly, the ilium, which is the pelvis. The fourth one is the sesamoid bone. The function of this bone is to protect the tendons and diminish friction and wear on the joint surface. This type of bone is usually small and round, and that is found in the hands, feet, and knees. A common example of sesamoid bone is called patella, which is the kneecap. And lastly, the irregular bone. Basically, if it's not listed above, it's an irregular bone. These types of bones vary in size and structures, and the shape may be complex. Irregular bones serve different functions depending on location. For example, vertebrae protect the spinal cord, and hyoid bone maintains tracheal and pharyngeal support. So we are now in the functions of skeletal system. So let us know what are those functions. So first is support for the body, movement, protect internal organs, blood cell production, storage of minerals, particularly in calcium, and lastly is the growth and development. I know that most of us already know this one, but let me share this to you. So, did you know that the adult human skeleton system contains 206 bones? The human skeleton provides the body with a multifunctional structures. It also consists of the joints, cartilage, tendons, and ligaments that connect them.
Structural functions. Like the fragmentation functions, the structure functions sometimes referred to as the protein structure functions is probability density function in physics. It resembles the form factor and the structure factor from solid state physics in several ways. Consequently, the fundamental principle of structure function is used to express the motion that there is always a link between structure and a biological entity. Functions of structures. Letter A. To support. For example is, the legs of a chair are designed to support the weight in the user in chair. Letter B. To contain. For example, the shell of an egg is meant to contain and protect the inside of the egg. Letter C. To protect. For example is, the helmet is designed to protect the users. Two groups of skeleton. We have two groups of skeleton. These are the axial skeleton and appendicular skeleton. Axial skeleton is made up of the 80 bones within the central core of your body. This includes in your skull, which is the cranial and facial bones, ears, neck, back, which are the vertebrate sacrum and tailbone, and rib cage, which is the sternum and ribs. The appendicular skeleton. What is the appendicular skeleton? The appendicular skeleton is comprised of the upper and lower extremities, which include the shoulder, the girdle, and pelvis. The shoulder girdle and pelvis provide connection points between the appendicular skeleton and the axial skeleton to where mechanical loads transfer.
Influencing bone health. Diet lacking in calcium increases the risk of fractures, early bone loss, and lower bone density. Physical exercise. Physically sedentary people are more likely to develop osteoporosis than physically active people. Alcohol and tobacco usage. What are the things that we need to do in order for us to keep our bones healthy? I have a few simple steps to prevent or slow our bone loss. For example, including plenty of calcium in your diet. For adults ages 19 to 50 and men ages 51 to 70, recommended dietary allowance or RDA is 1000 milligrams of calcium a day. Recommendation increases to 1200 milligrams a day for women age 51 and older, and for men age 21 and older. For example, dairy products, almonds, broccoli, kale, canned salmon with bones, sardines, and soy products like tofu are all excellent sources of calcium. If it's hard for you to consume enough calcium through diet alone, talk to your doctor about taking supplements. 2. Pay attention to vitamin D. Your body needs vitamin D to absorb calcium. For adults ages 19 to 70, the RDA of vitamin D is 600 international units or IUS a day. The recommendation increases to 800 IUS a day for adults age 71 and older. Salmon, trout, for example, salmon, trout, whitefish, or other olive fish are excellent sources of vitamin D. In addition, fortified foods like milk and cereals, as well as mushrooms and eggs, are excellent sources of vitamin D also. Additionally, sunlight helps the body makes vitamin D, and your doctors about supplements if you're concerned about obtaining enough vitamins. Include physical activity in your daily routine. You can strengthen your bones and reduce bone loss by engaging weight-bearing workouts like walking, jogging, and climbing stairs. Number 4. Steer clear of drug abuse. Avoid smoking. Avoid consuming more than one alcoholic beverage every day if you're a woman. Men should limit their alcohol consumption to no more than 2 drinks each day. Why is bone health important? New bone is always being formed and old bone is constantly being broken down in your bones. Once bone mass increase when you're young because of your body produces new bone more quickly than it degrades existing bone. Around age 30, the majority of the people reach their peak bone mass. Following that, you continue to lose slightly more bone mass than you gain as a result of bone remodeling. How much bone mass you have by the time you are 30 and how quickly you lose it afterward determining how likely you are to develop osteoporosis, a disorder that makes bones weak and brittle. The more bone you have in the bank and the higher your peak bone mass, the less probable it is that you will get osteoporosis as you get older. What affects bone health? These are the numbers of factors that can affect bone health. Number 1, the amount of calcium in your diet. Number 2, physical activity. 3, tobacco and alcohol use. 4, sex. 5, size, age. 7, race and family history. 8, hormone levels. 9, eating disorders and other conditions. And last, certain medication.
Kinds of muscle fiber. So before we proceed, let us know first, what is muscle fiber? Muscle fibers are a component of muscle tissue. One muscle cell makes up each muscle fiber. They aid in regulating the body's physical forces. They can enable coordinated movement of your limbs and tissues when gathered together. So, what makes a muscle fiber? A myofibril bundle, which consists of filaments grouped in segments known as sarcomers, makes up single cell called a muscle fiber. Actin protein strands that have been coiled around tropomyosin protein strands are what make up 10 filaments. Myosin, a protein, is used to make thick filaments. Muscle fiber has 3 types. These are slow oxidative, or known as SO, long distance exercises like marathon running mostly utilize slow oxidative muscles. They are located in areas of our body like the upper legs and back that demand a lot of support. Fast oxidative, or means FO, in middle distance activities like running or swimming, is a 400-meter race. Fast oxidative muscles are chosen since they tire slightly quicker than slow oxidative muscles do. Fast glycolytic, or FG. And lastly is, fast glycolytic muscles have few mitochondria and a limited supply of oxygen. They seem white because they have extremely few myoglobin molecules in them. Due to the enormous diameter of the muscle fibers, a strong contractive force is generated. They contract quickly because they degrade ATP quickly.
Muscle tissue properties. What is muscle tissue? So, muscle tissue consists of cells with a unique capacity to constrict or shorten in order to cause movement of the bodily components. The tissue is packed with blood vessels and has a high cell density. Muscle tissue has four main properties. Number 1, stability. Stability has the ability to respond to stimuli. Second, contractibility. Contractibility has the ability to contract. Third, extensibility. Extensibility has the ability of a muscle to be stretched without tearing apart. Lastly, elasticity has the ability to return to its normal shape. For more explanation, the muscular system constructs to carry out the following important matters, such as producing force and movement, supporting the body, altering posture, stabilizing joints, generating body heat is to maintain a normal body temperature, and giving the body shape. Even though they generate heat energy, muscles still need energy to function. Although anaerobic chemical reactions are also required, the oxidation of fats and carbohydrates provides the majority of the energy for muscles. Adenosine triphosphate molecules are created as a result of these chemical processes and are consumed by myosin filaments during muscular contractions. Function of muscles. What are the main functions of the muscular system? The main function of the muscular system is a person can move, speak, and chew thanks to their muscles. They manage the digestion, respiration, and heartbeat. The muscular system is also involved in processes that might appear unrelated, such as controlling body temperature and eyesight. Let's move forward. How the muscular system works. First, skeletal muscle. The weight of the whole body is made up to 30 to 40% skeletal muscles. They are the muscles that attach to your bones and gives you the range of motions and abilities. Since skeletal muscles are voluntary, you have the control over when and how they contract. Next is smooth muscles. Everywhere in the body, smooth muscles is found and performs a number of jobs. It assists with digestion and nutrients absorption in the stomach and intestine. It is found throughout the urinary system, where it aids in maintaining electrolyte balance and helps the body get rid of pollutants. Lastly, cardiac muscles. Cardiac muscles is in full control of the heart's ability to contract and as the result, the pumping motion. The heart muscles must contract with sufficient force of the blood flows to meet the body's metabolic needs. The formula for this idea, called cardiac output, is a heart rate x stroke volume.